Alright, so this week I'm going to talk about the coastline paradox. And before I start, just keep in mind kind of what I talked about last time with the Coke snowflake, and then I'll kind of relate the two because they have a lot in common as we go. So this quote is from the Pickover book, and it says, it's just kind of explaining the coastline paradox. As one uses increasingly small measuring sticks to measure the length of the coastline of England, the length of the coastline appears to approach infinity. This paradox shows how natural features exhibit fractional dimensions over a range of measurement scales. So in that first sentence it says basically the smaller of a measuring stick you use, the larger the coastline will appear to like the length will be. Just kind of how the Coke snowflake, when the sides got shorter and there became more of them, it became a longer perimeter around the outside and kind of approached infinity. So I'll kind of show an example of that here. So if this is that's our coastline of England, and this is going to be our measuring stick. We'll go around and measure it. So there would be 1, and 2, 3, 4, 5, 6, 7 and a half, just about. So I'll put that length up here on the board. If we're going to do this again, what we use half the length of the measuring stick, so I'll just fold it in half here, and we'll measure again. So there's 1, 2, 3, and you can see since it's kind of shorter, it fits along more of like the curves around the length of the coastline. So there's 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, pretty much just 17. So if you doubled 7.5 of the regular ones, that would be 15, and since we're using half the length, 15 would be the same thing, and we got a little over 17. So you can see it'd be a little bit longer the smaller we use, and then just go on and continue to get longer. So some of the major contributors to the coastline paradox were Lewis Fry Richardson. He was a British mathematician and meteorologist. He was looking into the coastline paradox because he was studying the correlation between the number of wars and like the number of boundaries a country had with other surrounding countries. And what he found was the more borders a country had with countries around it, the more wars it was likely to have. And then Mandelbrot here, he took it upon himself to continue Richardson's work, and he found kind of a relationship between the length of the measuring device and the length of the perimeter you would get as your result. So, and when he was looking into that, that's how he discovered the fractal dimension, and that's just the dimension he discovered of how rough or irregular a surface is. And some of the effects that had on life, he inspired many to look into his fractal dimension more and explore that. People who use it are like scientists that can use it to study steel strength or like growth of lungs in infants and stuff like that. And another big thing is graphic design. They use it to animate things, like especially things in nature, because nothing in nature is like perfectly smooth. So they kind of go hand in hand there. Also, the coastline paradox is also a fractal, just like the Koch snowflake was, because no matter how far you zoom in on the coast, it's always going to kind of be like curvy and bumpy. So like if you were viewing it from above like this in a helicopter, you'd see like the curves of the coastline, but then if you got down on the land and you just saw what you saw from standing there, it would also be curvy. And then if you pulled out a microscope and you looked at it through the microscope, you'd also see bumps from like the sand and stuff like that. So there are my sources. That's what I got.